All right, guys, today's flipped lesson is over 4.5, using congruent triangles. Make sure you have your own sheet of paper to take notes, or you can print out the guided notes that are linked to the calendar. Let's get started. The first thing that I want to do is I just want to review the 4 ways that we have learned to prove triangles congruent. Okay, so we have side, side, side. Side, angle, side, where the angle is in between the congruent sides. Angle, side, angle, where the congruent side is located directly in between the congruent angles. And angle, angle, side, okay, where that side is not located in between the congruent angles. Keep in mind that, and I'll do this in red, okay, that angle, angle, angle does not prove triangles congruent, and also angle, side, side does not prove triangles congruent. So just keep in mind, these 2 are common errors that I frequently see. Okay, so I just wanted to remind you of the 4 ways that we do prove triangles congruent versus the 2 ways that are common errors that do not work. All right, so now let's build off of this idea. What does CPCTC stand for? Well, it's a longer phrase, which is why we abbreviate it, but it stands for corresponding parts of congruent triangles are congruent. All right, so corresponding parts of congruent triangles are congruent. Okay, we're going to use this when we're asked to prove that corresponding parts are congruent. Okay, which we'll see in this next example. But first, you have to prove that the triangles are congruent before beginning the process. Okay, so basically if I can prove that triangles are congruent, then I'm allowed to conclude that any of their corresponding parts are congruent. So let's take a look at one example. Given that AB is congruent to AD and BC is congruent to CD, they want us to conclude that angle, let's see, I want my highlighter, that angle BCA is congruent to angle DCA. So that is our goal. Our goal is to prove this blue angle congruent to that blue angle. Okay, but in order to do that, we first need to just prove the triangles congruent in general. So let's get started. I have my given information. And also BC is congruent to CD. Given, given. Okay, I also notice that they share a side. So that means that AC of the top triangle must be congruent to AC of the bottom triangle by the reflexive property of congruence. Now, I think that we can conclude that triangle ABC is congruent to triangle A corresponds with A, B corresponds with D, C corresponds with C, by side, side, side congruence postulate. Well, now, if we have proven that these 2 triangles are the exact same, this angle has to be congruent to that angle, which is what we were asking for at the beginning. So angle BCA must be congruent to angle DCA because corresponding parts of congruent triangles are congruent. Okay? So we proved the triangle's congruent, and then we made a conclusion that one of their corresponding parts had to be congruent. Let's look at another example. Notice that it's asking us to prove PQ okay, congruent to RS. So they're asking us to prove a corresponding part congruent to another part. Well, that's a dead giveaway that we're going to be utilizing CPCTC. So just based on that statement alone, I know that we're going to be using CPCTC at some point. So that means my first step is to prove the triangle's congruent in general. So let's get started. All right, PS is parallel to QR. That's given. And I'll mark it in my picture. Now remember, I gave you a hint. Anytime you have parallel lines, you are going to look for congruent angles. So we'll do that in just a minute. Okay, the next given is that QPS is congruent to SRQ. So let's mark that in the picture. Let's see, QPS is congruent to SRQ. All right, so since we're dealing with those parallel lines, let's look for those congruent angles for just a second. PS is parallel to this line. If we cut it by a transversal, then I see that this angle has to be congruent to that angle. So let me sketch that out. Angle PSQ is congruent to angle RQS because alternate interior angles are congruent. All right, I also notice that they share a side, right? QS of the left triangle is congruent to QS of the right triangle by the reflexive property of congruence. Now, do we have enough information to conclude the triangles are congruent? I think so. So PSQ, triangle PSQ is congruent to triangle. P corresponds with R, S corresponds with Q, Q corresponds with S, by angle, angle, side. Notice that the congruent side is not located in between the congruent angles. Now we can make our conclusion. PQ must be congruent to RS, right? Because corresponding parts of congruent triangles are congruent. All right, let's look at just a few more examples that illustrate this idea, and then you guys can move on to your own practice problems. All right, so take a look. We have some parallel lines. I'm going to start with my statements, my reasons. Notice they're asking us to prove that AB is congruent, okay, to CD. So AB congruent to CD. That's a dead giveaway that I'm going to be using CPCTC because they're not asking me to prove triangles congruent. They're asking me to prove a part congruent. All right, so let's get started. First, I'm going to mark my given information. AB is parallel to CD. Also, BC is parallel to DA. Now remember, anytime you have parallel lines, we're going to look for congruent angles. Well, we have two sets of parallel lines, so it looks like we're going to have two sets of congruent angles. This line's parallel to that one. Let's cut it by the transversal. So what I'm noticing is that this angle is congruent to that angle. Let's make the statement. Angle ABD is congruent to angle CDB. Because alternate interior angles are congruent. All right. Then we have another set of parallel lines. So let me just kind of get rid of that for a second. Parallel line, cut by transversal. So look at what I notice. That angle has to be congruent to that angle. For the same reason, alternate interior angles are congruent. So angle CBD is congruent to angle ADB. Alternate interior angles are congruent. All right, I also notice that they share a side. So BD of the left triangle has to be congruent to BD of the right triangle by the reflexive property of congruence. Now I think that we're good to conclude that the triangles must be congruent. So triangle ABD is congruent to triangle. All right, A corresponds with C, B corresponds with D, D corresponds with B. Okay, by angle, side, angle. Notice that the congruent side is located directly in between the congruent angles. Now we know for a fact that AB must be congruent to CD, right? Because corresponding parts of congruent triangles are congruent. All right. So guys, that brings us, this is our final example. So what you are going to do is you guys are going to now upload your notes to Shobi. Okay, then you're going to attempt the 4.5 practice problems, and we will discuss those in class tomorrow. Good luck.